It's a closed circle, so it's the brackets instead of the parentheses. It includes -4, it includes the point -4, and then we have the arrow going forever. So on the x-axis, that's infinity. Good. And then the range, I shouldn't put it. The range is your y. So on your y-axis, up and down, what's your lowest point? What's your highest point? Well, my highest point is just an up arrow, so it's going to end the same way. It's going to end with infinity, right? What's the lowest point on the y-axis? My x was -4, my y was -2, so my range is -2 to infinity. It includes that point, so it's a bracketed -2. Is that okay for the domain and the range? It sounds intimidating, especially with 3 different parts to the graph, but it's just looking at what they gave you, okay? So that's the domain and the range. The domain is -4 to infinity. The range is -2 to infinity. And then intercepts, where did it cross, right? It crossed here. We know what that one is, right? That's x equals -2. Y equals 0. And then we don't know where this one crossed, but, oh, sorry. Here's another intercept, 0, +2. Shouldn't ignore that one. And we have a hard one over here. It's crossing the x-intercept again. We don't know where, but remember, we know that this equation is f of x equals x² - 5. Good. And we know it's crossing the x-axis. So if it's crossing the x-axis, that just means we make y 0. So f of x is 0. So 0 equals x² - 5. Just solve for x now. Add 5, add 5. 5 equals x². I want to undo that, so I'm going to square root it. If I square root it, I have to make it a positive and a negative. So positive or negative square root of 5 is equal to x. Good. And which one do you actually see? Do you think that this is x equals this negative square root of 5 or the square root of 5? Because it's only going to be included from here on out, right? So we're only including this one. This does exist, but it would happen over here, and that precludes it. Okay? So this is the intercept, square root of 5, 0. That's the end of piecewise functions. Onto transformations. Transformation rules. All right, let's go over the transformation rules best we can. The methods of transformation are, you can shift them. Okay, so these first 4 are shifts. So vertical translation means you're going up or down. You're taking that whole graph. You're taking this graph. You're either moving it up the y-axis or down the y-axis, or you're moving it positive x or negative x on the x-axis. Good. Those are shifts. These 4. Okay. Vertical translation, up or down. Horizontal translation, left or right. This will never be in focus enough for me. Never. You have young eyes, though. You'll be all right. And then we have reflection. You can either reflect over the x-axis or you can reflect over the y-axis. If you had the graph, for example, of the square root of x, you can reflect it over the y-axis. So you're making a mirror out of the y-axis, or you can reflect it over the x-axis, making a mirror of the x-axis. Good. The last, oh, sorry. So those are reflections, or You can compress it or stretch it by multiplying or dividing. So a compression or a stretch, your original was in green. And then we either made it smaller or bigger on Y, or we made it wider on X, or we shrunk it on X. Okay, and we will go over all of those, but basically that's what you'll see. It's either shifting it up, down, left, or right. It's either stretching it or compressing it, or stretching it or compressing it on X or Y, or you're flipping it across the Y-axis, or you're flipping it across the X-axis. This is how you do it. This is how you change your coordinates. Okay, this is what it looks like when it happens to the equation. But we're going to go over all of that. Don't worry. All right. So transformations are when we make changes to the parent or base functions. That's why last class we went over. Stay. That's why last class we went over the parent functions. We can now make them more complicated. So if you just had the squared, or sorry, the absolute value of X, what if you add 3 outside those absolute value bars? What happens to that graph? Because we can picture the absolute value of X now, right? That just looks like a V right at the origin. It never goes below the X-axis. But what about if you add 3? Does that mean I go up? Does that mean I go right? Right? Okay. So the methods of transformations are horizontal X-axis shifts, vertical Y-axis shifts, compressions when you make something smaller, stretches when you make something wider, either on the X-axis or on the Y-axis, or you can reflect on the X-axis or you can reflect on the Y-axis. Okay. Vertical translations. Change f of X. Okay. If it's happening on the Y-axis, change the Y, but our Y is now f of X because it's a function, right? So if it's a vertical change, change the whole thing, change all of f of X, okay? If it's a horizontal translation, change only X, okay? Let's start with shifts. Shifts, again, look like this. So for your shift, you've got your regular, linear, f of X equals X, right? You're either moving it to the right, or maybe you're moving it up. Okay, those are shifts. Nothing changes except the location. Okay, you add or subtract, you pick up the graph, you move the graph, you don't change its size. All right. If you're changing it on the vertical, that means we're changing it on Y. Okay. Up means we're going to add. If we're moving it down, we're going to subtract. All right. Think about absolute value of X. Good. Absolute value of X looked like this. But what's the absolute value of X plus 3 mean? It means I moved it up. Zero, zero now becomes 0, 3. Good. Notice that I added it outside, not inside. If you added it inside, that would be a horizontal shift. See the difference? Okay. Now we're going down. That means we're going to subtract 3 from that original. back to that original graph. That's just y equals the square root of x again. Or sorry, y equals the absolute value of x. Now I'm going to subtract 3. Instead of 0, 0, I'm going to have 0, -3. Looks the same. Didn't change the size. Didn't change the direction. I just moved it. All right. Remember, horizontal is always going to mean x. When you're talking about x, x is opposite. So vertical makes sense, right? When we add 3 to y, we go up, we go towards positive y. When we subtract 3 from the y, we go down on the y-axis. However, horizontal, or the x-axis, left is negative, right? But left means we add, okay? So all your horizontal stuff is actually the opposite of what you think it's going to be when you just look at it. The absolute value of x plus 3 means I go up 3. The absolute value of the quantity x plus 3 means I'm going to go in the -3 direction on x. So x is counterintuitive. Remember that. So again, we still have the absolute value of x as our base. We're going to move it left. We're still going to add 3, but it's going to be inside. It's going to be right next to the x inside the grouping symbols. Okay. So this is going to be we're going from 0, 0 to -3, 0. We picked up the graph, we moved it that way. Because it's the x-axis, because it's on the horizontal, because it's a horizontal shift, it's counterintuitive. So a +3 means I move it in the -3 direction. Similarly, that subtracting 3 is going to move it in the positive x direction. So that's still 0, 0, 0. But I'm subtracting 3. So that means it now exists on the point +3, 0. And those are shifts. The y is intuitive, the x is counterintuitive. Don't forget that part. Other methods of transformation are compressions or stretches. So our example was something like this. If you were to stretch it along the x, it's going to do that. If you were going to compress it along the x, it might look smaller. If you were to stretch it along the y, it's going to look like that. And if you were to compress it along the y, it's just going to be a straight line. Good. We're still using the absolute value of x as our example. So here, we were just adding or subtracting. The difference is whether it's inside or outside the grouping symbols. Here we're multiplying it. So here, vertical still means y, right? Vertical still means y. Pulling or shrinking in the y direction. So multiplying by a number outside the grouping symbols means we're going to stretch it. Okay. You don't have to draw this every time. Here's my y equals the absolute value of x, but y equals 2 absolute value of x means what I've done is I've said y equals 2 times f of x. Good. So if this was the point 1, 1, and this is the point -1, 1, vertical stretch means I'm taking my y value and I'm multiplying it by whatever that number is. So it's still 1 on the x, but it's 2 on the y. Still negative 1 on the x, but it's 2 on the y. So I take y times whatever that number was. Still starts at 0, 0, because 0 times 2 is 0. But it's going higher. Good. All right. Compression, if it's a fraction. So this said vertical stretch, if the absolute value of A is greater than 1, vertical compression, if the absolute value of A is between 0 and 1, or if it's a fraction, okay? So if we're doing 1/2 x instead of 2 absolute value of x, that means it's actually going to be down here. You're going to cut for 1/2, for example, you're going to cut your y values in half. So this was 1, 1. This was negative 1, 1. This is now negative 1, 1/2, positive 1, 1/2. You're just multiplying your y values by the fraction. For example, y times 1/2 here, and over here it was y times 2. Ooh, negative f of x? Yes. Negative f of x is a reflection. Somebody asked this. Negative f of x is a reflection over the x-axis. So down here, here are your differences, okay? If you have the square root of x, here's our original square root of x, right? We did this last class. That's just f of x equals the square root of x. If there is a negative outside of the square root, that means it is negative f of x. The whole thing is negative. So that's that one, right? So you're reflecting it over the x-axis. Think about which one's the x-axis. It's this one. Reflecting it means you're holding up a mirror or you're folding this over. And if it was like wet paint, it would make a pattern. So f of x is negative square root of x, because think about this. F of x is the square root of x, right? So the square root of x is the square root of x, but we made it the negative square root of x. Negative square root of x is the negative square root of x, which is the negative of all of that, right? So when you put the negative out in front of the whole situation, that's a negative f of x. But here, we're just making the x's negative. So that's going to be, sorry, I'm jumping around. So that's going to be same square root of x, but now only the x is negative. So it is reflected on the y-axis. This is your y-axis, so you're mirroring it across the y-axis. So that's going to be looking like that. So negative f of x means it's a negative outside the grouping symbols. The whole thing is made negative. So you reflect it over the x. If only the x's in the equation are made negative, reflected over the y. And I know this is seems convoluted because we only have one example, but as you practice it, it will make sense. And these are very good questions. So I skipped over those two in this order as you look at this guy. And we jump to vertical stretch and vertical compression. So vertical stretch means that this is a whole number. Vertical compression means that this is a fraction between 0 and 1. Good. The difference between vertical and horizontal is, just like with the addition and subtraction, right? If you added it outside the grouping symbol, it had to do with the y-axis. If you added it within the grouping symbol, it had to do with the x-axis. Okay. If you put the negative outside the grouping symbol, it had to do with the x-axis. Dang it. If you put it inside the grouping symbol, it had to do with the y-axis. Sorry, not great. But here it follows. So it's outside the grouping symbol, it has to do with the y-axis. Now that it's inside the grouping symbol, it's going to have to do with stretching or compressing along the x-axis. Good. So now we are at horizontal, pulling or shrinking in the x direction, which means, as we know, left to right. So here we have y equals the absolute value of 1/2 of x. So here was our original. Remember, just like okay. Just like it was counterintuitive over here, +3 inside the grouping symbol moved us on the -3 on the x. -3 within the grouping symbol moved us to the positive 3 on the x. Here, multiplying by a fraction is actually going to stretch us out on the x. Okay? So you are taking your x, in this case, and you're multiplying it by 1/2. Okay, so instead of 1, 1, you now have oh, sorry. 1 times x times 1 over 1/2. So x times 2. So instead of 1, 1, you have 2, 1. Instead of -1, you have -2, 1. So that y is very intuitive. You multiply it by whatever that term was. But for x, you're multiplying it by the reciprocal of that. So you're putting that number under a fraction. Compression, it's going to shrink it down. So here it's being multiplied by 2. So x is being multiplied by the reciprocal of 2, which is 1/2. So here's our original 1, -1, 1. Sorry, +1, 1. Not perfect. And then we have it being multiplied by 1/2. So instead, now we have 1/2, 1, -1/2, 1. So it's narrower, a bit sharper. Good. So that's what your graphs look like as we talk about this. And I know that took a lot of time. That's what we're working with. Here's a cheat sheet for it. Reflections. If it's outside the grouping symbols, reflected over the x. If it's inside the grouping symbols, reflected over the y. So here's a more thorough explanation. Vertical shifts are not grouped. So if it has to do with the y-axis, it's not in the grouping symbols. It's outside the square root. It's outside the square root, all right? Y equals f of x plus k is the parent function shifted up k units. Y equals f of x minus k is the graph of the parent function shifted down k units. If you look at horizontal shifts, you see that the h is inside the grouping symbols with the x, okay? I have an error there. All right, so let's talk about vertical shifts, just a bit more detail. I know we don't have very much time, but if you think about the graph of, it shouldn't be going back down, it should be going out. Running out of time. So here is my graph of the square root of x, right? So this is just f of x. Then we say, what is f of x plus 2? If this is the point 0, 0, and this is the point 1, 1, and this is the point 4, 2, right? We're moving up if it's positive, or we're moving down if it's negative. So what's happening is g of x is moving up 2. So instead of 0, 0, we're going to start at 0, 2. Instead of 1, 1, we're going to add 2 to each y value. So it's still 1 on the x, but now instead of 1, it's 3. 4, 2, it's still going to be 4 on the x-axis, but it's going to add 2, so it's going to be 4, 4. So that's just a vertical shift up. For the vertical shift down, we're going to subtract 2 from every y point. Vertical translation down. Y minus the quantity you're moving it down. So instead of 0, 0, it'll be 0, negative 2. Instead of 1, 1, it will be 1, negative 1. 4, 2 moved down 2 from 2 to 0 will just be 4, 0. So those are the vertical shifts. You add k to each y value or subtract k from each y value. Horizontal shifts, again, they are counterintuitive. So we've got our graph of absolute value of x, right? That'll just be g of x equals the absolute value of x. If you want to subtract 2 within the grouping symbols, that means that you need to go right. So if this was 0, 0, 1, 1, negative 1, 1, we're just going to move all of those right 2 units. So now that's 2, 0, 3, 1, 1, 1. Notice that this is subtraction, but it's moved in the positive direction. So this was g of x equals this absolute value of x minus 2. And then we also have plus 2, which means we're shifting it left 2 units. So instead of 0, 0, I'm going to have negative 2, 0. Instead of 1, 1, I'm going to have negative 1, 1. And instead of negative 1, 1, I'm going to have negative 3, 1. So those are just horizontal shifts. We picked up the graph and we moved it somewhere else. Remember, horizontal is the opposite to the sign. If you're subtracting, you're moving it right. If you're adding, you're moving it left. Horizontal will be inside the grouping symbols. Like that. Those are all grouping symbols. All right, so for this example, they want us to describe the transformations and sketch them. So think about what the parent is. The parent here is f of x is x squared. All right, and then because of this -3 within the grouping symbols, right? That -3 means I'm going to move it, right 3 units. Right 3 units is positive on the x, so it's opposite the sign, right? So that -3 means I'm moving it right 3 units. This +2, it's outside the grouping symbol, so that means it has to do with the y-axis. That means it's going up 2 units. So I'm taking x squared, I'm moving every point on x squared to the right and up. X squared, we learned last class, we learned on Monday, it looks like this. Just roughly assuming right 3 up 2 means I'm going to start it here and just follow those same rules. So you don't need to plot each point. You just need to know what this looks like, move one of its points, draw it again. Okay. Or you can, right? We know this is 0, 0. If I move it right 3 units, that's going to be a 3 on my x-axis. If I move it up 2 units, that's going to be a 2 on my y-axis. So I added 3 to x, added 2 to y for every single point. You're also welcome to do that. All right. One more time. Here we have the absolute value of x plus 4 minus 3. Good. So our parent function was f of x equals the absolute value of x inside the parentheses. We have a +4. Remember, we're doing the opposite of the sign. So +4 would mean right on the x-axis, but the opposite is left on the x-axis. And then that -3 is outside the grouping symbols. So that is related to the y-axis. We're going down 3 units for every point on that graph. So you got that. A good place to start is always 0, 0. Left 4 units, down 3 units. So it's going to be very negative, right? 1, 2, 3, 4, 1, 2, 3. And instead of 0, 0, I now have -4, -3. Again, these are all, they are not compressions, they are not stretches, and they are not reflections. They are just shifts. You're just picking it up, moving it somewhere else. Okay. You can move it both up and to the side at the same time. If you are multiplying by the x, if you're multiplying by the entire thing, that would be multiplying by y, or you're multiplying just within the X, that would be a horizontal compression or a shift, okay? So a vertical compression or a stretch is obtained by multiplying each y coordinate of the parent function by a. So it's a compression if it's a fraction, it's a stretch if it's not a fraction. G of x equals 4 times the square root of x. It's outside the grouping symbol, so I know it's vertical. It has to do with the y-axis. Good. The graph of the parent function, right? Here's the parent function, is stretched vertically by 4. Again, feel free to use this guy. What's happening here? The f of x is being multiplied by 4. So I would call it this one. Good. Here, if something's added outside, here, if something's added or subtracted within the grouping symbols. Here, if the 4 is in front of the x's grouping symbols. Here, if the 4 is within the grouping symbols. Good. So you just kind of look at which one of these is it? How did it change? Because I know the parent function was just the square root of x. Now there's a 4 outside of it, so that looks like this one. The 4 is outside the entire thing. What do I need to do? I just need to take that 4 and multiply all of my y values by 4, and I will get the correct graph of it. Okay. So this means that g of x equals 4 square root of x is the graph of the square root of x stretched vertically by 4 units. Every y value is multiplied by 4. I know we don't have any time. And then I've been repeating a lot, but just want to make you feel confident. So confident that you're bored of me, maybe. 0, 0, 1, 1 on the square root of x, right? And then we got, I went way too high, 4, 2, 9, 3, etc. Right? Now you're going to take every y value and you're going to multiply it by 4. You're still starting at 0, 0 because 0 times 4 is still 0. But 1, 1 becomes, my y is now multiplied by 4. 1, 1 becomes 1, 4. 4, 2 now becomes 4, 8. So you can see it stretching along the x-axis. And I will have to stop there because we are out of time. We will go through the rest of this quickly, just because it is, I think it's hard to learn. And so if we see it twice, that will help us. Thank you all so much.